Exercises. Question 1. Fill in the blanks. 1. The phenomenon of splitting of light into its component colors is called dash. The answer is: the phenomenon of splitting of light into its component colors is called dispersion. 2. Very fine particles mainly scatter dash light. The answer is: very fine particles mainly scatter blue light. 3. The phenomenon of change in the dash of light when it passes from one transparent medium to another is refraction. The answer is: the phenomenon of change in the direction of light when it passes from one transparent medium to another is refraction. 4. The refractive index depends upon the dash of propagation of light in different media. The answer is: the refractive index depends upon the relative speed of propagation of light in different media. Question 2. Rewrite the following table in such a way that column 2 and column 3 matches column 1. The answer is 1. Dispersion is splitting of white light into component colors, and it gives the spectrum of 7 colors. 2. Scattering is reflection of light by small particles, and it gives the blue color of the sky. 3. Refraction is change in the direction of ray of light due to change in medium, and it causes the twinkling of stars. Question 3. Answer the following. First, what do you mean by dispersion? Name the different colors of light in the proper sequence in the spectrum of light. Answer. 1. The splitting of white light into its constituent wavelengths is called dispersion of light. 2. White light splits into the following colors: violet, indigo, blue, green, yellow, orange, and red. Second, explain how formation of rainbow occurs. Answer. 1. A rainbow is a natural spectrum appearing in the sky after a rain shower. 2. It is caused by dispersion of sunlight by tiny droplets of water present in the atmosphere. 3. A rainbow is always formed in the direction opposite to the sun. 4. The water droplets act like small prisms. They refract and disperse the incident sunlight, then reflect it internally, and finally refract it again when it comes out of the raindrop. 5. Due to this combination of various phenomena, different colors reach the observer's eye. That is, a rainbow is formed. Third, what is refraction of light? How is it related to refractive index? Answer 1. When light travels from one transparent medium to another transparent medium obliquely, the direction of propagation of light in the second medium changes. This phenomenon is called refraction of light. 2. The extent of change in the direction of the light ray is different for different media. It is related to refractive index of the medium. 3. Greater the refractive index of a medium, greater is the bending of light. Question 4. Give reasons. First, the sky appears dark instead of blue to a person located in space. Answer 1. The molecules of air and other particles of atmosphere are very tiny in size as compared to the wavelength of visible light. 2. When sunlight passes through the atmosphere, these fine particles scatter light of different wavelengths. 3. Blue light gets scattered the most by the fine particles. Hence, the sky appears blue. 4. However, when astronauts fly at higher altitudes, there is no atmosphere there, so scattering of light does not take place. Hence, the same sky appears dark. Second, stars twinkle at night. Answer 1. Layers of air have different densities. The density of air decreases as we go above the earth. 2. Due to difference in densities, the light entering the Earth's atmosphere undergoes refraction continuously before it reaches the Earth. 3. Since the atmosphere bends the light coming from the stars towards the normal, the apparent position of the star is slightly different than the actual position. Four. Stars are very distant objects and hence they are point sources of light. 5. When the atmosphere refracts more light towards us, the star is seen bright, and when it refracts less light towards us, the star is seen dim. 6. The amount of light reaching the Earth changes as the apparent position of the star is not stationary but changing slightly. Hence, the stars appear to twinkle at night. Third, the sun appears reddish early in the morning. Answer 1. The sky appears blue since the small particles of the atmosphere scatter blue light. 2. Early in the morning, the sun is seen at the horizon. Near the horizon, most of the blue light and the lights of shorter wavelengths are scattered away by the particles. 3. Hence, the light that reaches our eyes is of longer wavelength, that is, red light. This gives rise to the reddish appearance of the sun. Fourth, it is possible to enjoy a rainbow at fountains in any season. Answer 1. The small drops of water formed by the fountains act like prisms. 2. When light enters these drops, refraction, reflection, and dispersion take place. 3. Due to this combined effect, light splits into a spectrum of 7 colors. Hence, it is possible to enjoy a rainbow at fountains in any season. Question 5. Write short notes on: First, refraction observed in the atmosphere. Answer 1. The density of air around the Earth is not uniform. 2. It is denser near the Earth, and it goes on becoming rarer and rarer as we go above the Earth. 3. The difference in the layers of air increases more during hot summer days. 4. Sunlight entering the air gets refracted repeatedly as it enters the Earth's atmosphere. This causes the apparent position of the objects present in the sky to change or shift continuously and gives a waving effect. 5. The twinkling of stars is an effect observed due to refraction of light in the atmosphere. 6. The stars act as point sources of light, and hence the light from them gets refracted continuously as it enters the Earth's atmosphere. 7. Due to this, intensity of light reaching the Earth varies, causing the stars to twinkle. Due to the refraction in the atmosphere, the sun appears bigger when it is rising and setting. Second, dispersion of light. Answer. When a narrow beam of white light is incident on a prism, the angle of deviation, which is dependent on the refractive index of the material and the frequencies of the constituent colors, is different for different colored lights. It is seen that violet color gets deviated the most and red gets deviated the least, as shown in the diagram below. The other colors occupy intermediate positions between red and violet. On emerging, the light spreads into a fan-shaped beam called spectrum. This phenomenon is known as dispersion of light. Due to dispersion of light through raindrops, we can see the formation of a rainbow after a rain shower. Question 6. Solve and fill in the blanks. First, velocity in first medium v1 is 3 into 10 raised to 8 meters per second. Velocity in second medium v2 is 1.2 into 10 raised to 8 meters per second. What is refractive index of 2 with respect to 1, and what is refractive index of 1 with respect to 2? Answer. Second, what is V1 when V2 is 2.25 into 10 raised to 8 meters per second and refractive index of 2 with respect to 1 is 4/3? What is refractive index of 1 with respect to 2? Answer. Third, when V1 is 2 into 10 raised to 8 meters per second, what is V2 and refractive index of 2 with respect to 1 when refractive index of 1 is 1.5? Answer. Question 7. Solve the following. First, the speed of light in a transparent medium is 2.4 into 10 raised to 8 meters per second. Calculate absolute refractive index of the medium. Answer. It is given speed of light in medium equals 2.4 into 10 raised to 8 meters per second. Speed of light in air is equal to 3 into 10 raised to 8 meters per second. Solution. Absolute refractive index is equal to speed of light in air upon speed of light in medium. Substituting the values, it equals 3 into 10 raised to 8 meters per second upon 2.4 into 10 raised to 8 meters per second, which equals 1.25. Therefore, the refractive index of medium is equal to 1.25. Second, the speed of light in water and glass is 2.2 into 10 raised to 8 meters per second and 2 into 10 raised to 8 meters per second, respectively. What is the refractive index of A. Water with respect to glass, B. Glass with respect to water? Answer. A. Water with respect to glass. It is given speed of light in water, that is VW, is equal to 2.2 into 10 raised to 8 meters per second. Speed of light in glass, VG, is equal to 2 into 10 raised to 8 meters per second. Solution. A. Refractive index of water with respect to glass is equal to speed of light in glass, Vg, upon speed of light in water, Vw. Substituting the values, 2 into 10 raised to 8 meters per second upon 2.2 into 10 raised to 8 meters per second. Thus, refractive index of water with respect to glass equals 0.909. B. Glass with respect to water. Refractive index of glass with respect to water equals speed of light in water upon speed of light in glass, which equals VW upon VG. Substituting the values, 2.2 into 10 raised to 8 meters per second upon 2 into 10 raised to 8 meters per second, which equals 1.1. Thus, refractive index of water with respect to glass is equal to 0.909 and refractive index of glass with respect to water equals 1.1. Third, refractive index of water is 4/3 and speed of light in air is 3 into 10 raised to 8 meters per second. Find the speed of light in water. Answer. It is given speed of light in air VA equals 3 into 10 raised to 8 meters per second. Refractive index of water equals 4/3. Solution. Refractive index of water with respect to air equals speed of light in air VA upon speed of light in water VW. Substituting the values, 4/3 equals 3 into 10 raised to 8 meters per second upon VW, or VW equals 3 into 10 raised to 8 meters per second into 3/4, which equals 2.25 into 10 raised to 8 meters per second. Therefore, speed of light in water is 2.25 into 10 raised to 8 meters per second.